So welcome to lesson 2, powers with negative or zero exponents. So in the first lesson, we reviewed what a power was. We also learned how to solve radicals. Now we're going to move on to laws and rules that we have when it comes to powers. So as I mentioned here, there are 3 definitions with respect to powers. We're going to talk about 2 in this lesson. The third one we'll talk in a later lesson. So the first definition we have with respect to powers is anything, so 0 as an exponent. It says a to the power of 0 is equal to 1. So anything to the power of 0 equals 1. The only exception to this rule is 0 to the power of 0, which does not exist, or it's meaningless. So what are some examples? If I say negative 5 to the power of 0, the answer is 1, because the base was negative 5 to the power of 0 gives me 1. If I have xy over 3 to the power of 0, again, all of this is to the power of 0, that just equals to 1. If I have 5x squared minus 7xy3 all to the power of 0, again, anything, this was the base, to the power of 0 is just going to give you 1. So that's the first rule that we have. Anything to the power of 0 will give you 1. I just want you to be careful here because you need to still identify what the base is. Here the base was negative 5 to the power of 0 is 1. That's fine. Here the base was xy over 3 to the power of 0 is 1. Here the base was 5x squared minus 7xy cubed. Again, to the power of 0 is 1. If I give you something like negative 5, so this is the next question, negative 5 to the power of 0. Keep in mind here that, again, the base here is 5. So 5 to the power of 0 is 1, but I still have that negative up front. So I have negative 1 times 5 to the 0, which is 1. So this gives me negative 1. So you still need to be aware of what the base is here because it's the base to the 0 that gets replaced by 1. If there's anything else like a negative 1 up front, you need to then multiply the negative 5 by the 1 to get your final answer. The second rule we have is negative exponents. If we have a negative exponent, so any power with a negative exponent can be rewritten to have a positive exponent. And here's the example. If we have a to the power of negative 2, all we're doing is we're going to rewrite it so that there's a 1 always on the numerator, and then we just copy this in the denominator, except for the negative exponent becomes positive. So let's look at another example. If I had z to the power of negative 4, again, the numerator is always 1. Then I copy this down below as my denominator, but the exponent, which was negative, is now positive. If I have 2 to the negative 3, again, my numerator is always 1. I copy this down to the denominator, but make the exponent positive, and so on and so forth. Again, this is complete review from last year. We're just kind of going through it quickly. So at this point, okay, I'm going to show you maybe 2 examples of each, and then I want you to pause the video and try these on your own. So we have something to the power of 0. The base is 12 to the power of 0 is just 1. Negative 3 to the power of 0. Again, the base is negative 3 to the power of 0 is just 1 again. Let's take a look at this. I have 12 to the power of negative 2. This is a negative exponent. I want to convert it to a positive exponent. So I keep the numerator, that doesn't change, and I copy this to the bottom, but instead of a negative 2 as my exponent, I have a positive 2. Here I can actually evaluate this because that's the same thing as 1 over 12 to the power of 2 is 12 times 12, which is 144. Let's take a look here. I have my base, which is negative 3 in this bracket, to the power of negative 3. So again, because I have a negative exponent, I will put a 1 at the top. Then I will copy this down below, but instead of a negative exponent, I have a positive exponent. So here I have negative 3 to the power of 3. Again, if you need to do that on the side, I'm going to just do it over here. So negative 3 to the power of 3 is the same thing as saying take the base of negative 3 and write it out 3 times. And negative 3 times negative 3 is positive 9, times negative 3 is negative 27. So this is the same thing as saying 1 over negative 27. So what I want you to do is I want you to pause the video. Maybe I'll do one more example of each. Then I want you to pause the video, and then I want you to try the last 4 on your own. So again, I have x to the power of 0. Something to the power of 0 is just 1, so that's fine. And here I have 2 to the power of negative 4. Again, I have a negative exponent, so I need to convert it to a positive exponent. So I have 1 on the numerator, and the denominator becomes 2 to the positive 4. So the negative exponent becomes positive. Again, I can solve this. 2 to the power of 4 is the same thing as saying 2 times 2 times 2 times 2, which you should be able to do in your head. 2 times 2 is 4, times 2 is 8, times another 2 is 16. So pause the video now, and then check your work. Okay, so you should have gotten these final answers. So this was a trick one. Remember, the negative is not attached to the base. The base here is 7. So if I kind of hide the negative, 7 to the 0 is 1. But because I have a negative up front, I'll multiply the 1 by negative to give me negative 1. So be careful with those. And here I have a whole complicated thing, but that's the entire base, and it's to the power of 0, so that's just 1. Here I have x to the negative 6, again, a negative exponent. So I could do 1 at the top divided by copying this, but making the exponent positive, so that worked. Unlike these previous questions, there was nothing to solve here because I don't know the value of x, so you can leave it as is. And here I have negative 3 to the power of negative 1. Again, be careful about what your base is. The base here is just 3. So this negative up front, I just copied as is. So I copy that negative. Here I have 3 to the negative 1. So I have a negative exponent. I put 1 as the numerator and converted the denominator to 3 to the positive 1, which gave me negative times 1 over 3, which is negative 1 over 3. So hopefully these two definitions are clear. Again, anything to the power of 0, so the base to the power of 0 will equal 1, but there could be things happening outside the base, so be careful of that. Like we saw in this example, there was a negative outside of the base. And if you have an exponent with, or a negative exponent, we can always convert it to a positive exponent by making a fraction, where the numerator is always 1, the denominator is the same expression we see here, except the negative exponent is now positive. So using these rules then, we can tackle harder questions. I can put multiple things together and we can do operations with these exponents. So again, remember BEDMAS. So brackets first, then exponents, then division, multiplication come together, and addition and subtraction come together. So let's take a look at this question. Following BEDMAS, there are no brackets, but there are a whole bunch of exponents. So let's solve that first. Here I have 4 to the negative 2. We have a negative exponent. So we're going to rewrite it with the negative exponent. The numerator is 1. The denominator is 4 to the power of positive 2. So that's great. I'm going to copy the negative now because I have exponents to deal with. I'll deal with that negative, the subtraction, later. And here I have 4 to the negative 1. Again, I have a negative exponent. Because I have a negative exponent, I'm going to convert it to a fraction again. So here I have 1 over 4 to the power of 1. Plus, I also have another exponent here, but it's not negative, it's positive. I can solve this as is. 2 to the power of 2 is 2 times 2, which is just plus 4. Now I can simplify this because I still have exponents here, so let's simplify it. Here I have 1 over 4 squared, which is 16, minus 1 over 4 to the power of 1 is just 4, plus 4. What I notice now is I have an addition and subtraction of fractions. We know with fractions we need a common denominator, so I'm just going to convert this to a fraction as well. To get a common denominator, Again, what we have to do is we have to find that common denominator and then make all the fractions, convert them so that they have that common denominator. Here, the common denominator between 1, 4, and 16 is 16. So here, this will stay as is. To get this term to 16, I'm going to multiply the top and the bottom by 4. So 4 times 4 will give me 16. And here, the top 1 times 4 is just 4. And over here, again, to get the bottom to 16, I need to multiply 1 by 16. So I also need to multiply the 4 by 16, which is just 64. Now that they all have the same denominator, when you're adding or subtracting fractions, the denominator stays the same, and you just add or subtract the top. So 1 minus 4 is minus 3 plus 64 is just 61. The last thing you would do is you would see if you can reduce this. In this case, we cannot. And so that's how we're solving these questions again. The definitions of the exponents will get us to an equivalent expression that we can now use tools we've learned earlier to actually solve them. So let's move on to the next question. It says 10 times all of this, so 5 to the 0 minus 5 to the negative 2. So when we think of BEDMAS, we think of brackets. Within our brackets, we have exponents and subtraction. The exponents need to come first. So I'm going to copy the 10 right now because I'm not dealing with it. 5 to the power of 0. So anything to the power of 0 is just 1. I'm not dealing with the subtraction now because I'm going to deal with the exponents first. And I have 5 to the negative 2. I have a negative exponent. I need to convert it. So that's the same thing as saying 1 over 5 to the 2. So again, I put 1 as my numerator and 5 to the positive 2 as my denominator. So I can keep simplifying because I still have that exponent. So I have 10, 1 minus 1 over 5 squared is just 25. I still have my brackets to deal with, so I'm still working on my brackets, but now I have a subtraction of fractions. I know with subtraction of fractions, I need to get the same denominator. So 1 is the same thing as saying 1 over 1. The common denominator between 1 and 25 is just 25. So here, I need to convert this first fraction so that it has a denominator of 25. So I'm going to multiply the top and bottom by 25. So I have 25 over 25 minus 1 over 25. Again, I still haven't gotten rid of the bracket, so now I'm going to do my subtraction. 25 over 25 minus 1 over 25 is 24 over 25. Again, I kept the denominator and just subtracted the top. Now, multiplication question. I know when I'm multiplying fractions, I know I should try to reduce. So can I reduce 10 and 1? Nope. 24 and 25? Nope. Then you go diagonal. 10 and 25? Yes, I can divide both of those by 5. So 10 divided by 5 is 2, and 25 divided by 5 is 5. And I also check the other diagonal. So 1 times 1 and 24, I can't reduce. Remember, you can only reduce in these directions, up, down, or diagonal. You can never reduce horizontally. So now we move on. Because we can't reduce any further, when we're multiplying fractions, we multiply the top. 2 times 24 is 48. And then multiply the bottom. 1 times 5 is 5. Let's move on to this next question. This next question is really fun, but it's also really annoying as well. So let's take a look here. It says half times 45 to the negative 2 times 38 to the negative 1 plus 128 all to the power of 0. Now your initial instincts are like, okay, I see brackets. Let me solve whatever's in these brackets, which is good, but you should also realize that after you solve this entire bracket, you're just going to put it to the power of 0. Now, thinking back to the rule, anything to the power of 0 is just 1. So this entire thing is my base. That to the power of 0 is just going to give me 1. So I didn't do anything with the half, so I'm going to copy that. But I know this entire expression, yes, this this part right here is going to equal 1 because that whole thing is to the power of 0. And so half times 1 is just half. Okay, so look for the things to the power of zeros first because those can really help simplify what you are trying to do. Let's take a look here. Okay, so we have 9, 3 to the power of negative 3 divided by 4, 2 to the power of negative 4, plus 6 to the power of 0. I'm just taking a look at this. I do want to clarify this a bit, this question. So I'm going to add a few brackets here. So I'm going to put brackets around here. I'm also going to put brackets around here, just so the question is a bit clearer. Okay, so let's deal with this. It seems like a lot of work, but let's deal with it slowly. So we have brackets here, so let's deal with those brackets first. Here I have a 9. I'm going to keep it as 9. And here I have times 3 to the power of negative 3. Again, that's a negative exponent, so I'm going to rewrite it as 1 over 3 to the power of 3. Again, because I had a negative exponent, the numerator was 1, and I copied this with a positive exponent. This division sign, I'm just going to rewrite as a regular division sign, just to make my life easier. And then I have this bracket as well. So let's deal with this bracket. I have a 4 multiplied by 2 to the negative 4. Again, I have a negative exponent, so I'm going to convert it to 1 over 2 to the 4 with a positive exponent, plus 6 to the 0. And we were only dealing with brackets, so let's just leave it at that. We're still dealing with the brackets, but within the brackets, we see that we have a whole bunch of exponents. So let's deal with that next. So here we have 9 times 1 over 3 to the power of 3, which is 27, divided by 4 times 1 over 2 to the power of 4, again, 2 times 2 times 2 times 2, which is 16, plus 6 to the power of 0, which is just 1. I still have my brackets, so let's continue to reduce these brackets. Within this reduce within the bracket. Within this bracket, I have a multiplication of fractions, because remember, 9 is just 9 over 1. When it's a multiplication, I see if I can reduce. I can't reduce this way or this way, but I can reduce diagonally. I can divide 9 by 3, which gives me 3, and 27 by 3, which gives me 9. And in fact, I chose the wrong number to divide by. I should have divided by 9, but that's okay, because I can still continue to divide these by 3. 3 times 3 is 1, and 9 divided by 3 is 3. So what I'm left with is 1 times 1 at the top, which is 1, and 1 times 3 at the bottom, which is 3. So I have 1 divided by 3, or 1 over 3, divided by, again, here I have a multiplication of fractions. So I see if I can reduce this way, and diagonally. To reduce diagonally, I can divide both of these by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So the top, I have 1 times 1, which is 1, and the bottom, 1 times 4, which is 4, plus 1. So now I have 1 over 3 divided by 1 over 4 times, plus 1. So I continue working. Again, with BEDMAS, I'll do the division first. So when I have a division of fractions, remember, I keep the first fraction, and I change this to a multiplication question by finding the reciprocal of the second fraction. So it'll be 1 over 3 times 4 over 1 plus 1. When I multiply the fraction, it will give me 4 over 3 plus 1. Now I'm left with adding fractions. Again, I need a common denominator for this, so I'm going to change my 1 to 1 over 1. The common denominator between 1 and 3 is just 3, so this is going to stay as is. To change this to a common denominator of 3, I need to multiply the top and bottom by 3. So 1 times 3 is 3, and 1 times 3 at the top is also 3. And when I finally add these, it gives me 7 over 3. So again, You have the tools to solve these questions. The only additional step is they give you some sort of exponent. You need to convert them to numbers, whole numbers first, before you, the exponent itself to whole numbers, the power itself to whole numbers, before you kind of continue and solve the question. Let's keep going. These are the last two examples. So here we have something that looks, again, super complicated, but let's follow BEDMAS. So we'll start with the brackets first. If I take a look at this bracket, there's really nothing to do there. So I'm gonna leave it as is for now. And then I have this bracket where I can solve some stuff within that bracket. Within this bracket, I have 289 to the power of 0. We know that that's just 1. And the -7 was unaffected, so I'm going to copy that. So now I have a multiplication, exponents, and a multiplication. With BEDMAS, exponents come next. So here I have a negative exponent, which means I need to convert it. When I'm converting this, my numerator is going to be 1. My denominator is going to be the same thing, but the negative exponent becomes positive, multiplied by -1/7, which I didn't touch yet. I keep going because I still have an exponent here, so I have a negative times 1/(-1) to the power of 3. Again, if you need to do this on the side, do it on the side. -1 to the power of 3 is -1 times -1 times -1, which is equal to, so 1 times 1 times 1 is 1, negative times negative is positive, times negative is -1. So I have -1 at the bottom times -1/7. So here we have a multiplication of fractions with a whole bunch of negatives everywhere. So let's take a look at the negatives first. The negative and the negative would be positive, times this negative will be negative. Here, the top, the numbers is 1 times 1, which is 1, and the bottom is 1 times 7, which is just 7, giving me -1/7 as my final answer. The last question here is we have all of this to the power of -1. Something I want you to remember from our first unit is we hate improper fractions. Sorry, we hate mixed numbers. We love improper fractions. So we want to convert this mixed number to an improper fraction. So when we're converting this to an improper fraction, remember, the denominator stays the same, and I multiply these. 6 times 1 is 6, and I add whatever I have at the top. So 6 times 1 is 6, plus 5 is 11, to the power of -1. So I know it's weird because we have a fraction, but we follow the exact same rules. It's a negative exponent, which means I need to change it to a positive exponent. So this is the same thing as 1/, remember my numerator is always 1, and my denominator will be 11/6 to the power of +1 instead. This looks funny as well because it's a division. It looks like a fraction with a fraction in the denominator. Sometimes you want to rewrite these. So the way I would rewrite this is the same thing as saying 1 divided by this entire thing, which is 11/6. And now it seems more manageable because now I just have a division of fractions. Remember, 1 is just 1/1. When I'm dividing fractions, I keep the first fraction. I get the reciprocal of the second fraction and just multiply through. So 1 times 6 is 6, and 1 times 11 is 11. So what I want you to do for homework is do handout C, and then again, you're going to submit these questions in our Google Classroom. Thank you.